to deliver a talk on context-driven AI agents. Before I start, I want to give a little bit of an introduction about myself. So I'm Shubhangi. I work at Admiral. I worked before that for 5 years at an AI startup. I'm also a Microsoft MVP on AI platforms. And I've spoken on multiple different events, some of which obviously you can see on the screen, some of which I have not put because obviously there wasn't much space left. And then, I also write tech blogs, work mostly in data science and AI space. And I also run a non-profit, Women in Data, basically in the London region, which is mostly about women who want to build a career in technology and data space, and they don't have enough resources. So if you also want to join, please feel free to reach out to me on that as well. So let's start from the beginning. Everybody in this room aware about generative AI? Yeah. Have you used any of the AI platforms? So you must know a little bit about what AI is all about and what prompt engineering is. But this talk is not focused about any of that. It's more focused on context. So when we give any instruction or any language and we communicate with AI, we generally use prompt. And prompt is a means to, it's a way to communicate and give instruction on how to use it. But you must have seen that a lot of times it gives wrong answers, which is classified as hallucination. And that largely happens because we haven't provided context. If you have asked me about context engineering a couple of months ago, it was probably something very, very new. But now I think it's all out there in the market, it's everywhere basically. So the biggest question is why is it important, and why have LLMs become so much more important that everybody in the market, everybody basically in tech is talking about it? There are many reasons, but I would summarize 4 of them. The first one is because it became sophisticated. Every single time a newer version was released, it had larger amount of data on which it was trained. There was much more information, and there were multiple different platforms created by different companies like Claude from Anthropic, there is ChatGPT from OpenAI, and there are many more in the market. Second is the movement of large language model to not just being a tool that answers. It's not like Google Chrome, hey, you wrote something and you get an answer. It became more like a strategic partner. When I say a strategic partner, I mean people started seeing large language models as more than something which could be used for automations, create something which can give them speed and autonomous execution at the same time. And then third and fourth are pretty simple. It can deal with complex business environments. If you're working in an industry type, you can customize them, you can tailor them. And then lastly, process data from multiple different sources, because that's how they are built. And then next question is how prompt and context fit into those 2 things. So prompt is basically about phrasing the instruction, which means how you communicate. But context is about building the system around the model. So now you have created a prompt where you are seeking information about, for example, you are traveling somewhere, or you're trying to execute a task, but that's like phrasing. But you haven't provided the context. Context is about how do you tell it exactly what to do and how to do, and what's the background of it. To understand it more simply, I will discuss about context window first. So context window essentially is about having a chunk of data on which you can frame the whole thing. So a lot of agents that are built today, they're focused on memory, which means there's some sort of dynamic memory involved. So if you see in a very simplified way, this is how a context window looks like. You have multiple different words and you decide which word you want to pick. And if you read here, I've clearly mentioned that a larger context window is more useful compared to a smaller context window, because it helps to make sure that the large language model knows what amount of data to use. So if you see this one, there is a target token I have taken, which means the focus of this conversation. So if I'm making a conversation about executing a task, what's my focus? So this is the target token window. Then there are obviously multiple information to the left, right, there could be any amount of information. I have to pick which side I want to go for. And that's how a context window is used largely. That is what provides more accuracy to the AI agents that are everywhere and people are talking about it. If you see closely, for example, this is one of the piece of context window I have picked. In mathematical form, if you look at it, this is how it is signified. Basically, let's say this is your center part of the context window, and everything towards the left is signified as negative, everything towards the right is positive. But obviously in programming it works differently. You have to code exactly and customize it to make sure your large language model picks up the right. So example, you're working in a financial industry or medical or legal, and you are trying to, let's say, understand a document. You're trying to figure out what it means. So you have to tell exactly what document is about, because on the top level you have one single vertical, but then deep down there are so many different playing parts. Maybe you're looking for, I don't know, policy data. Maybe you're looking for example, some sort of risk data. You're looking for something very, very tailored. So you have to make sure your context is set right in the first place before you start building any kind of model for your AI agents and also using LLMs effectively. Now, conceptually, this is how it looks like. You have a prompt engineering structure here, then RAG, which is your retrieval augmented generation. Here is your state or history, which is basically your memory. Here you have structured output, whatever output you're gonna get. And then outside all of that is where the context engineering sits. So it's not like it's a small chunk of it, it's the bigger part of the whole thing. Now, what is context engineering? Somebody asks you tomorrow, how will you explain that? That's also a thing. A lot of people know it, most people can't explain it. Simply because they haven't understood in depth what it is about. So if you read here again, it's used to provide the right information. Every LLM application you build has to be systematic and reliable. Building application that nobody uses isn't really effective. So context engineering plays a big role because it guides the behavior. It tells what is to be used. And then for making that work, you need memory. Now there are multiple type of terms in the industry right now, but largely there is a short-term memory, which is for shorter sessions, like a 30-minute session or maybe like a 15-minute session. What it does is it tracks any ongoing conversation. So for example, the way you used to use a browser, right? You have a memory, it remembers your previous conversations. The second one is long-term memory, which a lot of people want to use, but extremely expensive because of the APIs involved. That is about knowledge and preferences, or example, history across sessions. So without memory, remember this thing very clearly, the AI will reset every single time. It will not remember who you are, so it's important. And with memory, it is adaptive. So it will remember who you are, what you have asked, what's your preferences, anything about yourself. And that's why on conversations where you have stored some information, the large language model is able to recall or remember what the previous question was and give slightly more tailored answer. But that happens only when there is an adaptive memory involved. So how does building context look like? So firstly, for example, if you're writing a context, so you have, for example, two scenarios. So the first one is cross-agent, which means like you have multiple agents. So I was in one of the talks, somebody asked me like, if I build a multi-agent system, how does it work? So cross-agent obviously requires larger memory, but you can again pick the context window, because if you build a system with a very, very big memory, it's gonna be really, really expensive in real time. So you have to make sure that you optimize for the window you pick. Then second is, for example, within agent session, which is like very easy, like the 30-minute session or 40-minute session you're trying to create. For that, you don't require significant resources compared to this one. So you can erase the memory once it's done. So this is useful, for example, you're trying to create more like a user authenticated session where the user logs in and the AI has to remember every single thing. Now, second question I was asked was, and this is the reason why this slide exists, is like, how do we decide which context window to pick? So this is how you select. Firstly, you retrieve any kind of relevant data or tools available. So example, I am looking for data around risk or maybe like some sort of policy, right? I'll only pick that context first. And then I will make sure what kind of memory I'm looking for. Am I looking for a short-term memory, a long-term memory, how long this conversation is gonna go? So based on that, I'll retrieve the long-term or short-term memory for which I have built the agent. Then the third question I was also asked is like, okay, I picked the context, maybe I know which memory type I want to use is. I also want to know how to compress it, because there is so much information. You have trained your large language model on 1,200 articles or maybe more than that data. How do you shrink it? Like, how do you optimize it? So for optimizing it, there are mostly like a lot of approaches, but two main approaches is like you summarize your context, which means you only take important information. So in software, there's a concept of garbage in, garbage out. If you put everything, the LLM gets confused, doesn't know what to choose really. So you pick up the relevant tokens, summarize it. Basically, this large language model becomes a very smaller language model, which is a bit ironic, but yeah, it's a smaller large language model. And then lastly, if you have to remove any irrelevant tokens, you make sure you use chunking or some sort of prioritization technique to reduce the size of your bigger model. And then lastly, there was another question somebody asked me is also about how do we isolate the context, because if you have so many different smaller language models, sometimes you can still get confused, right? It can mix two things together. How do you isolate? How do you make sure one type of context is used. So for that, you can use 3 different approaches. For example, you can create a state, which means like an active state, where an active context is being used and the other 2 are sort of not active, where it basically knows that this is the first context I will use. Second is you can create a sandbox, which is like a temporary environment in which one of the contexts is higher prioritization, it gets activated. And then lastly, you can also partition it, which means like, again, like a bigger context can be divided into smaller pieces of information, which I call as topic islands, but people have different names for it. It's just a simpler way to remember things. So the bottom line is you have a top level of large language model. From that top level, you decide which part of that model you want to use. You don't use the entire thing. You chunk it down and shrink it into smaller parts so that you're optimizing that model. And then last but not the least, you're making sure that when your agent is active, it chooses the right window, the right context. In summary, this is what these 4 different images basically summarize. It's a bit complicated, but I have better information in the next slide. So how do you understand the life cycle? So this is like, that was more like on the technical level. Now let's go from the conceptual level. So the first part is acquisition. I am a user and I want to understand the data, right? I want to acquire data from different sources. Like these are, for example, we are 50 people, for example, here, maybe less than 50 people. You are all data for me, right? I want to acquire every information I can. And I'm building an agent around identifying who which person is. So that's like user acquisition. I fetch everything that is available and create like a memory out of it. Then second is processing. So I have the information, but hey, I don't need everything, right? So I will structure it, which means I will put them in a structure, maybe like a database sort of thing, and prioritize that information. This is my top information, this is low, I don't want that much. Then when I've processed, I will store it effectively in some sort of memory, which means like it could be short term, long term, depending on what kind of agent I'm trying to create. Then once I've stored it, I'll retrieve that information, which means I'll use some sort of querying, like we use in databases, a querying method. And every system that has data also needs updates because things change over time. Today something is relevant, maybe it's not relevant tomorrow anymore. It happens every other day. So the last step is extremely important, modify or expunge anything that is not needed anymore. And this goes on, it's like a continuous cycle. And if you look at the top level, like this is how the context workflow lifecycle moves. You have to remember these 5 steps every single time you're building it so that you are grounding the data perfectly. And the last step is extremely important. A lot of people don't do the last step, and it's actually applicable with most of the systems you build. Even like as basic as dashboards. People build a dashboard and they leave it and they expect it to like work all the time same, but you require to make sure that you're modifying and updating information time to time so that the right data is being used. Now, when people build it, how does the architecture flow? So in the start, the first was the step. You have an input, there's a text information, there was a large language model, and there was an output basically. Then we were like, oh, this isn't enough, we want some more information. So we used another box outside LLM, which is more like we started giving some context, some information that, hey, like I want a more reliable and accurate answer. So I started giving some context. But again, the answers were not accurate. So I went to the third step. What I did was I generated a RAG system here, which means I wanted more accurate answers and more reliable answers. Sorry. So here, the context still exists. I've added some more tools, which means like I've provided some KB articles. By KB articles, I mean knowledge base, maybe some grounded data, maybe some information already available. So I made it more accurate. But that I would say is generation 3. That was again not enough because I still wanted images and videos and all sorts of information. So in step 4, I added images and videos and like a lot more information essentially to make it a bigger thing, like not just like something which can work on text. Then when that was done, I thought, the LLM doesn't remember anything. The agent doesn't remember who I am, what I asked, so what do I solve? How do I solve that thing? So here in this step, if you see, there is a vector database and semantic databases. So a lot of people still don't know why vector databases are important because vector databases actually are a bit faster than normal databases. And here I added short-term, long-term, and a third type also, which is called episodic memory. So short-term, long-term is something we discussed in the start. Episodic is more like when you occasionally use it. which means like you don't like use all of your resources. You just use a resource, maybe like you have a conversation for 10 minutes, you're trying to solve a problem or automate a flow, or maybe like 15 minutes. So you don't have a standardized time, but you use it whenever you need it. So this is where I was, and then I also added a decision layer here, made LLM rethink, like kind of feedback loop, that is this answer correct? Do I need to redo the whole thing? So this became more sophisticated from the first step we were at. And then lastly, this is where it is going. This is basically the most sophisticated architecture of an AI agent. It includes a lot more information. So there is 3 different types of data, not just one layer of data. There is a real-time set of data you can use. User feedback, for example, every time your LLM fails to give a good answer, you can provide a feedback to it that the answer wasn't good enough. There is an orchestration layer on the top where there is like a task allocation, like I'm automating some tasks. For example, things like, can you check number of records in this data set? As simple as that. Maybe I'm not writing a query anymore. There is an inter-agent communication, which is like when there are multiple different agents. One agent is probably used for example, emailing, second agent is booking meetings, third agent is doing something else. So there is a communication layer. In the middle, there is planning, reflection, tools use, all different things that are basically done by the agent. Now, one question I want to like recall is like somebody asked me, why do we have model 1, model 2, 3, and 4, or maybe more? It goes back to the previous slide, number 4 we had. When we use a bigger model for one or more type of task, it becomes difficult for the large language models to remember what was done. So if you create a shorter language model, like a smaller large language model, it helps them to remember every single step that was performed and like find the right context. So making smaller models actually works better than building a larger one. And then if you go down here, there is like a layer for data storage, which is mostly around vector databases, any structured, unstructured input. You can provide any kind of data there. And then the last one is data governance, which is very important. A lot of people actually get stuck in this layer because they haven't figured out exactly how to solve it. If you have any PII data, remove it in the first place, or have some controls or GDPR laws, because this layer is extremely important for most of the businesses, actually every business. So like safety and control and ethics, which are basically a part of data governance layer, is extremely important. And if you see the last part, which is your output layer and service layer, that's where you generate the output. That's where you will find most customizable ways of looking at it. Now the outputs can be tailored. Like you can control the way the outputs are generated. You can give it like a scripted answer, or you can make it more customized. So I can give one example here. So one of the scenarios I worked on was like, there was a question, and every single time, even with the grounded data, I was giving the same prompt, it was giving me a different answer. And so the client comes and tells me, we don't want this because we want the large language model to give same answer, consistent answer basically, because that's what they want. And even though you explain them, hey, the deviation is probably like very less, but they will not take it. They still want same copy of answer. So output layer basically is something you can customize. So what happened was I performed multiple rounds of testing to make sure and find how much deviation was every time an answer was generated, okay? And the grounding had to change multiple different times. It wasn't enough to just ground data once. And that's why building smaller models works better, because the smaller models finds targeted data needed to give an answer. Without targeted information, they don't know, because it's a pool of information. It's like an ocean. Where do you want to land? Like, where do you want to go? So make sure that this is something, if you are trying to build an AI agent for yourself or for your organization, you always make sure that this is something you can reuse, like when you build it. And that's how like this was like a 6-step process of how you actually build like an AI agent. So which tools and frameworks you can use? I mean, there are a lot in the market, and a lot of people have different approaches and things they say. So I use LangGraph. I know there are a lot of limitations with LangGraph, and Langsmith, mostly for tracing, observability, or any kind of long-term state control. Then the second is vector DBs. So, and Llama Index for the context retrieval engine, because they are faster. They can actively work on semantic data. And then the third is orchestration libraries, which you can create using multiple agent systems. Now, I also want to mention some limitations, because people build it But like when you are working in engineering, right, you always want to create something really amazing. This is how we operate. But a lot of times you over-engineer things. We we create things which are not really needed sometimes. So a lot of times people over-engineer context pipeline, which means like either too much information, too less information, not targeted. You need to know what your target is. Like it doesn't work that way. Then second is validation. Like if you haven't performed enough testing, negative testing or validation of your data, like your cases where it can break, where it can work better, it creates a lot more problem. Then the third is context drift. So if you remember the image I showed, there is like a big pool of data. If you didn't set your context properly, it will just go here and there. So very, very targeted information. You have to program it so well that it knows where to go, because it requires a lot of engineering skills to build it. And then lastly, token limits are actually a bigger problem, because even with all the compression and optimization, there are cases where you will get like limitations in terms of tokens, because they cost money. Let's be honest about it. They cost money. Every time you have like, you ask a question, the API gets a call, it costs a lot of money. So token limit is real. So do not underestimate them. It's like one of the major things, because a lot of people do. And then when you are in the end of the project, you're like, this is not like a reliable use case anymore. So make sure all these limitations, which are real limitations, are actually thought of in the start before you start using what tools and frameworks I will use, what kind of data I'm going to use to build that context, what is my phrasing, what is my answer. Like all these things have to be thought in the start, not after it's built. Now, one very important part is feedback loops. How many of the people in the room have heard about it? One. Anyone? Okay, no. So just a little bit about feedback loops. This has happened, like this question was asked several times to me. So I added this slide simply to discuss about it. Feedback loop, if you read here, they are like a way to improve the large language model, which means like you tell it is not working, it's not giving you what you want. So it reviews the output, the scope of what you have given. And then, for example, verification is one of the way. For example, you verify the answer if it's right. So you're trying to pay your council tax and you want to validate the value it has given is right. So you will have, for example, your previous receipts and stuff. You would know that this is the amount I have to pay. So you verify that information. And that's one of the simplest use case. Obviously, people in the UK, everybody pays council tax. So you can think, if it is not giving you the right information, if you have provided all the, your name, your account number, everything, that means it is failing. It's not working. And some people will say, we have automated the entire thing and we are 100% confident that LLMs work, but you still need human in the loop, at least for many of the cases still, because you still need SME, somebody who can review the outcome, because you are 100% sure how the language model has worked. So what it does is it balances the automation with accountability. So if your large language model, your AI agent has failed, who is accountable for it? Who is responsible for that? So human in the loop basically helps to give feedback, corrections, and approval. So this is useful when you are testing that and making sure that all the negative cases, when you have like tested that, it actually breaks. It's not performing differently. So 2 + 2 is 4, it's not 5. Example, like it's not like actually performing differently. And what it does is basically, what you can do is you can also create goals, which is like testing it against some set of goals. For example, hey, my goal is to make sure that my meeting gets scheduled. Will it get scheduled on the right time, or for example, on an empty time slot? Did it get scheduled? So make sure you are like measuring it across like certain goals, and then did your customer, like for example, you are the customer when you're testing, did you accept the solution? So please make sure that like the testing is thoroughly done, because a lot of people do not spend time on testing them. They're rushing into production. Oh, like we have built this great agent, we just want people to use it. But testing is extremely important, because you have to break the system. You have to make sure you spend like some time. I recently went to a talk. Somebody said our model has improved our purchases by 40%. And I was like, how did that happen? Then when I asked that person after the talk, could you explain me a little bit about how that has worked? He said that the 40% part that he has improved was actually the 20% of the entire purchase. So the 80% was still intact, nothing changed there. So, which is actually a very small figure. But he said 40%, which gave me a perception that like they have actually improved it significantly. So again, make sure that the right way of communicating information is the key here. And do not just accept somebody telling you something. You should also like do your own like research around it, because there are multiple different ways of presenting same information. Do not believe that without any accountability that large language models actually really work. You have to make sure you understand all the inside parts, the engineering that has been done. Now, pitfalls to avoid. There are many, but 3 main pitfalls every single time will come. First is losing critical information. Make sure you chunk and prioritize. Chunk is a very popular technique used by machine learning engineers to like prioritize the data. So you basically break down your entire data into set of pieces, which I basically call topic islands, and then you can prioritize which one to use. Second is cost. Very big problem. So you have to get the buy-in and like all that process is done. So optimize workflows for efficiency. Like do not use a large language model completely, because when you go live, this will be a big problem. So make sure it's very targeted. And then lastly is governance gaps. If you are planning to build an enterprise use case and you have governance gaps, you know what will happen. So nobody will take that. So make sure you have built proper guardrails, removed any PII data, or have proper controls in place for that, and then only you're actually going live into production. So one of the use cases I want to discuss is, for example, when you call to a contact center and you have to wait several like minutes, 15, 20, 30, 40 minutes. And our time is precious, like we have only 24 hours in a day. You cannot spend, for example, 30 minutes or 45 minutes on a call. So you want to build, like, for example, an agent workflow. So LLM reasoning, basically what it does is it interprets the question that it has asked. Now you have an action layer, which is basically where you're putting all your data, like your knowledge base article. Then you are using natural language for response generation, which is the standard on a large language model. And then lastly, you have memory updates, which is like you are deciding what data I will change every single time or update. What I'm hoping to get by it is like, I don't want to wait 10 minutes. I want an answer within a minute. So I worked on a project for voice speech to text, and this was one of the requirements. We don't want to wait 10 minutes. We want an answer in 1 minute, so the agent should provide the answer. Like, we don't want it to connect to a human, basically. So what it does is like, in this case, the critical part was that to get the right answer, the grounding had to be really, really good. Grounding equals to how the context is made. So what it did was, after several levels of chunking, we were able to improve the consistency, basically the way the answers were produced, like same answers across the board. How do I pay my consultant? Like same answers, like. And they were based on knowledge, not guess. That's the key here. Sometimes in the initial phases of testing, it generated like false answers or false links, which were not leading anywhere, which is bad, right? Because like, how will somebody trust us that way? So the answers were based on the knowledge. And then lastly, the customers. So the people, they felt heard, which means like they understood that the agent was able to remember some of the past interactions that we had with it. So ultimately boiling down to the last point is like, why context matters. If somebody has still like not figured out, is like, AI basically gives generic answers. If you are working in a real-time scenario, you don't need generic answers. Second is, AI uses customer history, which means like your targeted memory, plus your knowledge base, which is like any specific information very targeted to the use case you are building. It could be a document, could be a knowledge base, could be like, it could be anything which is really, really specific to your domain, right? You have to use that so that it understands and gives accurate and trustworthy. Imagine a 60-year-old person used your application and it gave a completely false answer, and it's a real-time scenario. What will happen? So we have to think about every single person who is using that application. So that's why it's really important to make sure that you use it. You can also use past tickets, by the way. Jira tickets people have, or DevOps tickets. You can also use that, but you have to obviously structure your data. Data structuring, data engineering is really important. And so the final 4 key takeaways of this talk, if like nothing else, if you remember nothing else, is the first is like, if you want to make your agent adaptive, which means like it remembers every single time what you're talking about, make sure to grind the context properly. Second is architecture. If you don't remember anything, again, 3 things you will always need are the right large language model, right tools, maybe like you are using Azure AI, or you're using Vertex, or you're using LangGraph, Langsmith, whichever. And then you will need a right memory size for the use case. Third is prompt engineering is not going anywhere, it's still there. But it's just a part of the system, it's not the only thing anymore. Like people are like, oh, we will have this prompt engineering and everything will be solved. So you will still have it, but it's a part of the whole system. And then lastly, the real world impact, which is like, it depends a lot that if you're building an agent which is more robust, and you're designing something which actually skips some of the pitfalls, and like not increase your project timelines. And with that, my talk comes to an end. I am still available if somebody wants to ask any question. And if you want to reach out to me personally, you can obviously connect with me on my QR code. That's me. Thank you.